they have to pizza head such that if the maximum number of people will be able to get it, so they will find some relation, so they will check with the others. Now if previously there is something else, okay, some KFC is there or something, so how many people are going over there, or if some Domino's is there, how many people are going there, all this data, these data they will analyze, and also they will analyze if there is in a region, if they have to get in the region, how many houses will be accessible. So similar kind of things they will take, and they will set up a Pizza Hut in a region. Okay, so that also so in a way they are just calculating, okay, these many, okay, in a cluster this many people may come and get it. So they are just randomly predicting some regions to set up a Pizza Hut, because they actually don't know who all gonna get it. Okay, so only after they set up the Pizza Hut, and then if 1 month or 2 months gets over, then from the data they will know how much they will get the profit in future. But when they have to first do it, they have to go with this unsupervised learning method. Okay, that's how it is. This is like a simple kind of like an example. So now coming to this, so now I am just going, because most of you are from different backgrounds, I am going to the most basic, as I usually do. The most basic thing I'm going to explain for K means the steps. Okay, but when you go into deeper, the steps will have deeper things. Okay, you will don't confuse with that. I will just tell a little about how it is going to be later. So now just listen to this, okay? And those of you know already about this K-means clustering. Even today I saw someone had sent the K-means K-means implementation in Python. So those of you know, please don't confuse it. It is same as you would have done it, okay? But I am just explaining in the most simple terms as possible, considering the big group of people who are from the non-engineering background. Okay, so the first thing in K-means clustering is to define the number of clusters. So this number of clusters you will take, like randomly. Mostly you will just guesswork. You will be doing this K. Okay, so this K stands for the number of clusters. Okay, we are saying the K as K means because this K stands for the number of clusters. Okay, so there are different algorithms for taking the K. Okay, so for analyzing the K, there are different algorithms. One we call it as elbow method and Silhouette method. All these are quite famous, but then we are not going much into the detail of those, because we mostly in our problem we are just taking randomly the K. Okay, so when and then we will go with the other things. So this elbow method and Silhouette method is actually after taking randomly all the steps, then finally they will be calculating the K. Okay, so anyways, the first thing you can actually randomly take the K, the number of clusters. You have to decide how many clusters I can take it. Okay, that would be your that's your thing. And next is the centroid of each cluster. Okay, the centroid is the K-means clustering. It's a iterative process defined as this step, basically the starting point in each center. So K, how many K's you are taking, that is the centroid. Okay, centroid, as you know, it's the center of a region. So you are taking the K as the centroid. Okay, for each cluster you are having, now if I'm taking K as 2, so that means 2 clusters I have, so 2 centroids I'll be having. Okay, so next is the calculated distance of each data points to the center of each cluster. Then I have to calculate the distance. Okay, so for this calculation of distance also I have so many algorithms like Euclidean, then maximum, so many distance calculations are there. Okay, so here in this example they are just calculating a direct absolute distance. Okay, so those of you know Euclidean distance and all, don't confuse with the example I am giving. Okay, so next is the allocating the final clusters to all observations. And then you will be allocating the finite clusters to the all observation. You will calculate the distance and then you will check. Okay, so the minimum of the cluster value. So when I'm explaining the example, you will understand better. So minimum of the cluster value you will allocate it as a cluster. Then again you will be keeping on iterating these steps. Okay, so we'll see how it's going. So this is a example of a flower. Okay, so they had given the sepals and petal data they have. Okay, so now here the sepal length is given, the sepal width is given, petal length is given, petal width is given. You have to cluster it. Okay, you have to cluster it the various flower category. Okay, you only have the sepal length, sepal width, sepal petal length, and petal width. And I am here, I'm having some 6 observations over here. Okay, so now because I am having 6 observation, I can if I take it as one cluster, I mean it's of total waste. Okay, so we can't predict anything. So I will go with the 2 clusters. Okay, so now here I am taking the sorry. Here I am taking the cluster 1 and cluster 2 as now the third one and the 6th one. Okay, the third data, the third one and the 6th one as my k, or 2k as 2, and the third one and the 6th one I am taking as a centroids. Okay, the third one and 6th one, just remember this third one and the 6th one, these both I am taking as a centroids. And okay, so this is like this. Now first you are taking the k, first step is defined, 2 I have taken it, the third one and the 6th one I am taking as a centroid. So the next thing is I have to calculate the distance of each data points to the center of each cluster. Now next thing I am going to calculate the distance. Okay, so here this is my data, and I have my k is equal to 2, and then I have my step 2, that is the centroids. I have done it, and this is my calculated distance. My step 3 is a calculated distance. So how am I calculating this? I'm just taking the absolute values of each data with the center points or the centroids. Okay, so now here, can anyone calculate? Now here the first data I have is 5.1. Okay, so 5.1 minus 7. So how much it will be? Someone keep calculating this. Someone please calculate 5.1 minus 7. Can somebody calculate, just so that or you will get an idea of how it's coming? No one is having mobile or anything with you, calculator or anything? Am I audible? Are you all guys there? Hello?
Yes, ma'am.
Yeah, please do calculate, no? So what is 5.1 minus 7? Or you calculate 7 minus 5.1 if it is you are getting confused means.
Minus 1.9.
Minus?
1.9.
Minus 1.9. So I told you here absolute values we are taking. So we will, what is absolute value? The modulus of minus 1.9. The modulus of 1.9 is you will be taking the negative values. Any absolute value is like you will be taking the negative values. If it is positive values, you keep it like as it is. So it will be 1.9. Now next is 3.5 minus 3.2. Someone calculate.
0.3.
0.3. Okay, so next is 1.4 minus 4.7. 1.4 minus 4.7.
Minus 3.3.
Minus 3.3. So you take the absolute value, you get it as 3.3. Now 0.2 minus 1.4.
1.2.
0.2 minus 1.4.
1.2.
1.2. Now we got the values as 1.9, 0.3, 3.3 and 1.2. Now just add it. 1.9 plus 0.3 plus 3.3 plus 1.2. Just add all these. 1.9 plus 0.3 plus 3.3 plus 1.2. Someone add it. 1.9 plus 0.3 plus 3.3 plus 1.2.
6.7.
6.7. So here in the cluster 1. So sorry. So here in the cluster 1 we getting 6.7. So this is how we are getting the 6.7. Now when I am going to cluster 2. Now again we are going to the cluster 2 with the same data. So now 5.1 minus 5.8 is how much? Because I am doing with the sender 2 or centroid 2. Okay, so 5.1 minus 5.8 is how much?
0.7.
Sorry?
0.7.
0.7. Okay, now then for 3.5 minus 2.7.
0.7.
0.7 you are getting?
0.8.
0.8.
0.8, okay. 1.4 minus 5.1.
3.7.
0.2 minus 1.9.
1.7.
1.7. So now add all this 0.7 plus 0.8 plus 3.7 plus 1.7. 0.7 plus 0.8 plus 3.7 plus 1.7.
6.9.
6.0. So that is how we are getting here 6.9 in the first set of cluster 2. Okay, so now similarly each and every data, I mean from here each and every rows of data points are there, right? So we will be doing with the distance, we will be finding it with the center 1 and we will write it in this cluster 1, and similarly we will for with the center 2 we will find out and we will write it in the cluster 2. Okay, so here this is like they have done it in the Excel. So now here, so now here the next step. Okay, so we have done this. Okay, so now we have calculated the distance. Now we have to allocate the clusters for all the observations. So now clusters, how will you allocate this? We will take the minimum cluster value. Okay, so that is how we are going to allocate the clusters. So now here in this first thing, if you take it, you are having 6.7 and 6.9, right? So now which one is the minimum?
6.7.
6.7. So that belongs to cluster 1. So I am allocating it as cluster 1. So next thing, and I take it 6.8 and 6.6. So here the minimum is 6.6. That belongs to cluster 2. So I am allocating it as cluster 2. So next when I come to third one, then it becomes 0 and 2.6. So 0 is the minimum. So I am allocating it as 1. Okay, that because it belongs to cluster 1. Okay, now when we come to the fourth one, 0.9 and 2.1. So which one is the minimum? Which value is minimum? 0. is lesser or 2.1 is lesser? 0.9 is lesser, right? Are you all here? 0.9 is
Yes,
lesser
ma'am.
and it belongs to cluster 1. So I am having here as 1. Okay, this is how I am allocating the clusters. So there are 2 clusters given. So in that I will check the minimum and then I will allocate that as a cluster. Getting my point?
Yes, ma'am.
Okay, so this is how I am allocating the clusters. So but now we have allocated the clusters, so we will think, okay, now we have, so now here according to this first one, third one and fourth one belongs to the first cluster and the rest of them belongs to the second cluster. But we will be happy with that, actually it is done. But then actually in machine learning this won't happen as such. We will have so many, we'll keep on doing so many iterations. Okay, so this iteration we will stop when we take so many iterations, when the number of iterations is so much, when we take too many iterations, or when the clustering, when it comes the same cluster, same numbers come again and again, we stop. Okay, so now here next thing, I for the next iteration what I am going to do is I am going to take the average of the first clusters which I have got. Now I have got 1, 3 and 4. Okay, so this 1, 3 and 4 I'll take the, sorry, I'll take the, for the next centroid. Okay, so next centroid I am going to take the 1, 3 and 4 average. So 1, 3 and 4 average, in the sense what you will be getting, someone add 5.1 plus 7 plus 6.4.
12.74, ma'am.
Okay, divided by 3.
6.16.
Okay, so this is how I am getting the, so for the next centroid, for this next iteration, I am just taking the average. Okay, so here 1, 3, 4, I have to take the first thing. I am getting my centroid as 6.16. Similarly, now sepal width I'll go and again I'll have 3.5, 3.2 and 3.2. I will add and divide by 3. I'll get the next average as 3.3. Okay, so now next when I go to the center 2, I'll be having my next things, that is 2, 5 and 6, which I have already, why I am doing this, because I had made it as made 2, 5 and 6 as second cluster. That is why I am going for the average of 2, 5 and 6 as a second cluster, that's centroid 2. So average I'll be taking. Okay, so I'll be getting 5.6. So similarly, now I will fill all the centroids for the second iteration. Now I am ready with the centroids for the second iteration. So now the second iteration I will do same thing I'll be doing for here. Here like first one, the class thing is there, no, 5.1, 5.1, 3.5, all this I will be finding the distance with the center. I have got it. Okay, so now again I'll be getting how you found out first, no, the same ways you will be getting the cluster and 1 and cluster 2 distances. Okay, so you'll be getting some distances. So in this similar way, I have to find out the minimum, which is the minimum. Cluster 1, I am getting minimum, or the cluster 2, I am getting the minimum. So in this case, the first one I am getting cluster 1 as minimum. So I will put a cluster as 1. Okay. So now when I go for the, so now I will fill all the clusters. I will identify all the clusters. Now I am going for the third iteration. So for again, we take the average and update the center points in iteration 3. Again, I am going to take the average. Okay, so here so here which all the things I will take the average, the first clusters. I mean that is first data. That is now if I have to take the 5.1 and 4.9, I'll take the average and I will put it over here in the next centroid. I will put it. 1 second. Next is Android, I'll put it. Okay, so now I again then I will take the calculate the distance. So after calculating the distance, then again I'll compare both the cluster 1 and cluster 2, which is the minimum. That cluster I will take it as the thing. So now when I see my iteration 1, these are the clusters I have got. Iteration 2, I have got this. And iteration 3, I have got this. Now when you see this iteration 2 and iteration 3 are same. So I'm going to stop with this because I have got my exact clusters which I wanted. Okay, first of all, I told you when the iterations are too much, you have done too many iterations, you can stop it. Otherwise, the ideal way to stop this is when you get the same iterations or the same clusters in the iterations, then you will stop it. Did you get the basic idea of how you are doing this? No confusion, right? This is a very basic idea of k-means. Very basic and very simple idea. No confusion, right? You all understood, no? Now how to take the distance. First, you will be taking the distance. For the first thing, we are not having any average. So we are directly taking 2. Okay, so we are just directly taking. I'm just randomly taking my centroids. Okay, randomly taking 3rd and 6th as my centroids. Okay, I'm finding out 3rd and 6th as my centroids. I'm just taking the distance between each with the centroid. Okay, and then I am just putting it as cluster 1 and cluster 2. Okay, so cluster so next, after finding all these things, so cluster 1, all the data points with my sender 1, and cluster 2, all the data points with my sender 2. I'll be finding out the distances, and then what I have to do is which is the minimum I will check, and then the minimum cluster number I'll put. So then I'm allocating those as the clusters. So now seeing these cluster values, I will take the average, okay, for the next centroid. For calculating for the next iteration, I'm taking this the clusters. Okay, so now the average I'll be taking. Okay, so average I'll take for the, and then with this average which I got, I will again take the distance. Okay, for each data points, I will again find out the distance as we did for the start. We did in the starting. Again, I will find for each data point with the average I have got here. Okay, and then with the distances I have got, I will compare it, and which is smaller, I will put that as a cluster. And next, again, now I have got that now these first data 1 and 2 I have got as 1. Okay, that's the first cluster I have got. So again, I'll take the average of these both, and then I'll put it in the center 1. I mean, for this next centroid. Next centroid, I'll be taking it. So now, fortunately, I have got both these. I have got the same clusters. Okay, so same cluster. So I could stop it with this. I have got a very optimum data that I could stop here. So I can finalize. So my data 1 and data 2 belong to the first cluster, and now data, rest of the data 3, 4, 5, 6 belong to the second cluster. Are you all clear with this? This is a simple and basic thing. So if you have learned much more, don't confuse with it. You're clear, right? Someone say yes or no?
Yes, ma'am.
Yes, ma'am.
Okay, so now, so the centroids, as you know, okay, so when you take this k means, no, this term centroids, always you will be hearing it. Centroid is what we are mentioning there as center. Okay, so this all the k number, how many k you are choosing, how many clusters you are choosing, that many centroids will be there. Okay, so now I just given the centroid definition, so that I mean sometimes in your like 1 marks or whatever it is puzzles it may come. Okay, so that centroid is the data point. It could be the imaginary or real at the center of the cluster. Okay, so we pick the centroid which is unique, like it shouldn't be repeating. That's what the centroid. So now the very next thing you will hear in this k-means clustering is the Euclidean distance. So Euclidean distance is actually the distance between the points, okay, the coordinates, okay, and this is actually given by the Pythagoras theorem. This can be called as Pythagorean distance also. So you would be all knowing what is Pythagoras theorem, right? What is Pythagoras theorem?
When a hypotenuse square is equal to perpendicular square plus base.
Yeah, so now this hypotenuse square will be equal to the, or the distance will be equal to the adjacent side square of the adjacent, sum of the adjacent square of the adjacent side. So here it's given d is equal to root of x2 minus x1 the whole square plus y2 minus y1 the whole square. So this is the, exactly this is the Pythagorean as well as the Euclidean distance. So this is how I am going to calculate the distance between my point A, that is x1 y1, and point B, x2 y2. So where we use this Euclidean distances, so you remember here, right? So we have calculated directly, directly we have calculated this 5.1 and it's 7, right? Yeah, 3 point, directly we calculated and we wrote, no? You remember, right? So here we directly taken 5.1 minus 7, we took the absolute value. Then 3.5 minus 3.2, we took the absolute value. Okay, so some cases or many cases, they'll be using the Euclidean distance for this. Okay, so there are some other ways of finding out the distance also. So Euclidean distance is quite famous in doing this stuff. Okay, so this Euclidean distance will be used for finding out the distance. Okay, so we just took the absolute distance. Okay, so now we are there, instead of that you would be using Euclidean distance also, and there are some other, the main usage of, mainly Euclidean distance will be used. So next you will be hearing some term called within cluster sum of squares, okay, or WCSS. Okay, so this the measurement is actually used to calculate the, kind of accuracy. Okay, so this measures the variable of the observation within each cluster. Okay, so within each cluster, how much variability is there? That is what it's calculating. So when it is higher means then the variability is higher between the observations. Okay, so now this, how you calculate this, you'll find the Euclidean distance between the given point and the centroid, and then you will iterate the process for all the points in the cluster and then sum the values for the cluster and divide by the number of points. How many points are that, you will divide it. Okay, so that's how you'll be getting this. So if the value is higher, you will know that the variability is higher. And then between clusters sum of squares. Okay, so that is BCSS. This term also you may come across. So this measures the variation between all clusters. So now now if the variation the first thing is like the observations in a cluster. This is the the variation between the clusters. Got it, right? This is inside the observations inside each cluster. You will be getting what, that is what WCSS. And this BCSS is variation between the clusters. Okay, how much each clusters are varying. Okay, this is the data points inside the cluster, how much it is varying, and here the how much clusters are varying. So now the large value indicate the clusters are spread out. So when the small value is there, the clusters are close to each other. Okay, so that is how you find you do this. Okay, this is another term you will be coming across. Okay, so now here this Python implementation, once you understand this, then the implementation of Python, you will get it easily from Google. So here you will be having, if you have data set, you can actually take the data set and do it. So in this example, this is a simple example which I have got. They are importing some from scikit-learn. They are importing make blobs. Okay, so the make blobs is why they are importing is for random data. So for you're taking a random data data, they are importing this make blobs. So this data, they are just giving some n samples as 200 and this features as 2, centers as 4. Okay, 4 clusters I am just noting, and then the cluster standard deviation I have mentioned as 1.8 for all the clusters. Okay, so this and then this thing for the random data. If you are having a data set, you need not do this. If you're not having a data set, and then you can just take one random data to just see how the clustering works. Then the rest of the things are same, like we are taking the pandas, numpy, then Seaborn. So for this clustering, you will be importing another one library called Seaborn. The next thing is matplotlib. You will be importing, and matplotlib inline. Yeah, I so told inline we are using for what? To get the plots in the Jupyter itself. When you are coding in the Jupyter, you will be getting on that screen itself. You will be getting. You won't get the pop-up or something over there. Only it will get it. So now here for visualizing the data, you are just that data what this is randomly generating, right? So that for visualizing, you can put the scatter plot. Okay. Then you are training the cluster. So for training the cluster, from the scikit-learn, you will be importing the k-means. So if it is like linear regression, you will be importing linear regression. Naive, you will be importing naive. So similarly here, you are importing the k-means. Okay, so now here the k-means already I have mentioned my sentence is 4. So now the clusters, when the clusters I have 4 clusters. Now I am just fitting my model. So model fit the raw data from the starting. So for anything over here, okay, so mostly for all the features or all the data, mostly it will be starting with 0. Okay, so from the starting with 0, I am just fitting it over here to generate the cluster. So this predictions thing is actually optional, because only if you have some idea about how much the clusters would be there, how much, then you can actually go with the predictions. Okay, so now here, I mean, here itself I had given the link for step-by-step process for this Python coding. So if you want, you can go through this. Okay, and I think only, I mean, I got only one student responding with the programming part. Only one student had told me that he'll be sending the all the assignments. Okay, so rest of all the people also please try to do it. Okay, so only if you try to do it, the coding part, you will understand. Or okay, I'm not sure how this certification is there with only the project. If you do, I mean, is it fine, or I'm not sure about it. But at least, even if it is a project, at least one algorithm you have to be sure. I mean, at least one algorithm you have to code it. So in order to find which you are comfortable with it, at least for that purpose, you have to check everything. Okay. So are you all guys okay with this k-means? You got an idea about how this k-means is going on?
Yes, ma'am.
Got it, right? Okay, the basic idea you have got it. So now you can go, moving forward, you can go and you can just explore the more of it. So whatever I have told, no, this with Euclidean distance, you can try it. And for k, for finding out, usually we will be taking randomly, we will take the k. Now we have taken ks2. So for that also you have elbow method. Another method is elbow method and Silhouette method. 2 methods are there. So I forgot to put it in the PPT. So these methods are used for finding out the case. Though it is randomly, we can do it. So an optimum value, they say mostly you will be getting the optimum, but then for that also we will be taking with the random values, and then only we will be able to check. Okay, so mostly we will prefer for random, but you can go check all these things also. This elbow method, Silhouette method, and whatever I said, no, WCSS, Euclidean distance, WCSS, and BCSS. Just go through and check it. Okay, so that, I mean, it won't be like that you don't know about all these things. Okay. So otherwise, this is a simple procedure. Okay, so k means is nothing but you keep on iterating till then you get the clusters that's the same. Okay, so for that, the first step, the steps are same. Okay, only the methods you are using would be different. First, you'll define the number of clusters. So then define the centroid of each cluster. Okay, centroid is nothing but the data points, the centroid point we are taking, and then calculate the distance of each data points to the center of each cluster. Okay, so and then allocate the final clusters to all observations. So we are allocating by taking the minimum of the clusters. Okay, so different people will be having different procedures for allocating the number of clusters, and then for finding out the distance, then allocating the final clusters. So these will be differing for different authors. So when you go check in the Google, this part will be differing. They'll be using different algorithms, but the basic thing, okay, over this is same. This is a basic ideology. Okay, only the methodology will be different for different people. Okay, they would have checked with they would have thought this would work better and they would have done it. But this is the basic thing. You all got it right. So when you go check it, don't confuse with the different terms. This is the basic thing. Only the methodology they use it for this might be different. All of you got it right? Did you understand what I said? Okay, the steps will be same for anywhere you go check. The steps will be same. Allocation of the clusters, then distance between the clusters and the data points, and then final allocation of the clusters. But they might use different algorithm for allocation of the clusters and for finding out the distance and for the final allocations of the observations. They might use different algorithm or different methods. But this basic thing wouldn't change. You got it right what I'm saying? Come on, yeah, say yes or no.
Yes, ma'am.
Okay, fine. So that's all for today. So here is I had given the link. I will share the PPT to you and try to implement. Okay, so if it is not, I mean, I find this as very simple. So I have taken this program. You can go explore and you can have your own program and you can try it out. You see whether you are getting the proper answer. Okay, and you can just submit, you can send it to my mail ID. So because as far as I till now I don't think there is some group or anything that you could send it. Okay, so I am also as new as you people. So now for the time being you can send it to me, and if anything is there I'll just forward to them. Okay,
And what is your email ID?
mara Mary dot.
Can you write it in the chat box?
Yeah, wait.
Thank you, ma'am.
We can also upload the classroom.
Sorry.
You can also upload the PPT on the classroom.
Okay, I mean, I'm not there as a teacher. I can't upload it.
No, I will edit you. I already
I
edited you.
don't. Okay, fine.
Yeah.
Ma'am, please upload that syllabus part as well.
Which one?
Ma'am, syllabus part and the other material.
Which part I didn't get? Come again.
Ma'am, the syllabus part at the starting of the session you said, no?
Syllabus. Okay, syllabus thing.
Yes.
Okay, that I will. Yeah. Okay, that's it for today. Thank you.
Thank you, ma'am.
Thank you, ma'am.